Hello class 12. Today, starting with this video, we are going to discuss about the nucleus. We are going to look into the nucleus. First of all, starting with the shape, size and density of the nucleus. Now talking about the shape, for all practical purposes, the shape of the nucleus is taken to be spherical. It's taken to be spherical. Alright, now talking about the size, the approximate idea about the size of the nucleus was given after Rutherford performed the alpha ray scattering experiment. So a rough estimate of the nucleus size was calculated in Rutherford's alpha ray scattering experiment itself, and it was shown that the size of the nucleus is of this order, 10 to the power minus 15 meters, whereas the size of the atom is bigger compared to the nucleus, of course. The size of the atom is 10 to the power minus 10 meters, or which is equal to 1 angstrom. The size of the atom is of the order of 1 angstrom, whereas the nucleus is smaller than the atom. In fact, 1 lakh times smaller, as you can see. Okay, 1 lakh times smaller than the atom itself, the nucleus is. That is why Rutherford said that the atom is mostly hollow, because the nucleus is 1 lakh times smaller than the size of the atom. Anyway, 10 to the power minus 15 meters is also called a Fermi, 1 Fermi, 10 to the power minus 15 meters. This is also called a femtometer, 1 femtometer. Alright? Okay. Now, after Rutherford's alpha ray scattering experiment, many scattering experiments were performed by different people. And from those experiments, it was found out that the volume of the nucleus is directly proportional to the number of nucleons inside the nucleus. That is proportional to the number of protons and neutrons inside the nucleus, or volume is proportional to, so to say, the mass number of the nucleus, because the number of protons and neutrons inside the nucleus is what is called the mass number. Now, since the shape of the nucleus is considered to be spherical, now the volume of the sphere is given by 4 by 3 pi r cube, where capital R is the radius of the nucleus. So we can write 4 by 3 pi r cube is proportional to the mass number, or let me write here. Or simply, we can write r cube is proportional to simply a, or r is proportional to a to the power 1 by 3. The proportionality sign can be replaced by an equal to sign, so r is equal to r naught a to the power 1 by 3, where r naught is an empirical constant. Now the value of R naught experimentally has been found to be 1.2 into 10 to the power minus 15 meters. So R naught is a constant. Its value is 1.2 into 10 to the power minus 15 meters. So we can write this equation as R is equal to 1.2 into 10 to the power minus 15 a to the power 1 by 3. So this is about the size of the nucleus. It's of the order of 10 to the power minus 15 meters, or 1 femtometer, or 1 Fermi, whereas the atom is of the order of 1 angstrom. Now let us quickly get an idea about the density of the nucleus also. You can pause the video and copy this. Let me write it over here. So number 3 is density Now what is density? Density is mass divided by volume. Now the mass of nucleus, if that is m, then this is small m into A, where small m is what? It is the average mass of the nucleons. Average mass of nucleons. Okay, now protons and the neutrons, they have almost very similar masses. Neutrons is a bit heavier than protons, but still the average mass we take it to be the same. So if m is the mass of a nucleon, then the total mass of the nucleus will be mass of a nucleon times the total number of protons and neutrons. And volume, we already know, volume V is equal to 4 by 3 pi r cube. Okay, so therefore density, you can do this yourself also. Capital D is mass by volume from the definition of density, which is small m into capital A divided by 4 by 3 pi r cube. Okay, now this thing can be written as density is m into A divided by 4 by 3 pi. Instead of r, we'll write this r naught a to the power 1 by 3. So this can be written as r naught cube into A, because a to the power 1 by 3 whole cube will be simply A. So this A and this A, they divide each other out, and therefore we see that the density is m divided by 4 by 3 pi r naught whole cube. So you can see that the density of the nucleus is independent of the mass number. We don't have a factor, which is the mass number over here. So everything is a constant over here. Mass m, the mass of the nucleons is a constant, pi is a constant, r naught is a constant. Okay, so what do we understand from here? What we understand is the density of the nucleus is independent of the mass number. The number of protons or neutrons does not has no role to play whatsoever with regard to the density of the nucleus. Okay, and the other thing that we get to know is that the density of the nucleus of different substances, different atoms, different elements will almost be the same. The density of different atoms, of the nucleus of different atoms, is almost the same. It has the same kind of value. Alright, so that is what we understand. So this is about the shape, size and density of the nucleus. Let us very quickly now also talk about something called atomic mass unit, denoted by a small u, sometimes also called unified atomic mass unit. Now, what is this atomic mass unit? Let us first try to understand that. See, we have a body, however big or however small that body be. So we have a standard weight to measure the mass of this body. Like we go to buy, some amount of potato. So what we do is we buy 1 kilogram, 2 kilograms of potato. Now how do we measure that 1 kilogram, 2 kilograms of potato? Because we have that standard weight of 1 kg or 2 kg, because of which we can measure the mass of the amount of potato that we are buying. It's the same thing for rice or different other things for which we want to measure the mass. Now we want to measure the mass of atoms, or say for that matter we want to measure the mass of a nucleus. Now these are very tiny things, we are extremely very small things that we are talking about. The mass of an atom will be much lesser than 1 gram. Okay, so even if we have a standard weight for 1 gram, we cannot use the weight of 1 gram to measure the mass of an atom. So we need to define a standard unit using which we can define or get an idea about the mass of an atom, or that of nucleus, or that of very small tiny particles like atom, nuclei, like an electron, proton, neutron, like that. So in order to measure the masses of very small things like protons, neutrons, atoms, nucleus, electrons, okay, we have defined a unit which is the atomic mass unit. Now how do you define it specifically or technically? Atomic mass unit is 1/12 the mass of the carbon C12 atom. Carbon, the isotope C12 of carbon is the most abundantly found, element or isotope in nature. Carbon C12. Okay, there are other isotopes also, that of carbon, but this is the most abundant. So therefore, we are using the most abundantly found isotope or atom of, carbon. So what we do is, say this is an atom of carbon. So this atom of carbon is divided into 12 equal halves. 12 equal halves we divide it. Okay, this is not equal of course, okay, but we divide it into 12 equal halves, and 1/12 meaning this part. One small part out of the 12, one small part I take out. So this is the magnified picture of that 1/12 part. So the weight of this or the mass of this is what is your atomic mass unit. 1/12 the mass of carbon 12 atom. So this 1/12 part of an atom of carbon C12 is what is your standard weight, so to say, called atomic mass unit. Okay. Now, how do we measure the mass or value of this 1/12 the mass of carbon 12 atom? Now what we know is 1 gram atom of carbon C12 weighs 12 grams. Now 1 gram atom means there are how many, what is the number of atoms in 1 gram atom of C12, or for that matter 1 gram atom of any element? Okay, the number of atoms will be Avogadro number of atoms. 6.023 into 10 to the power 23 number of atoms. So 1 gram atom of carbon C12 weighs 12 grams means Avogadro number of atoms of C12 weighs 12 grams. So if Avogadro number of atoms of carbon 12 weighs 12 grams, then one atom will weigh how much? So one atom of carbon C12 will weigh 12 upon Avogadro number grams. 12 by n grams. So this is the mass of one whole atom of carbon 12. But we are not interested in one whole atom of carbon 12. We are interested in 1/12 part of that whole atom of carbon 12. Okay. So therefore, what is 1U? 1U is 1/12 the mass of carbon 12 atom. Now the mass, one atom of carbon 12 is 12 by n grams. So 1/12 part of 12 by n grams, which comes out to be 1 by n gram. So this 1/12 part of carbon 12 weighs 1 by Avogadro number grams, which is of course 1 by 6.023 into 10 to the power 23, this many grams, and it comes out to be 1U comes out to be 1.6605 into 10 to the power minus 27 kilograms. This is the value of one atomic unit. So knowing atomic mass unit, we can get an idea about how heavy an atom is, an atom of a particular element is, how heavy is it compared to this value, or how light, how light or how heavy a neutron is compared to this value. So we get an idea about the heaviness or lightness of a particular small thing like a neutron or proton or an electron, or for that matter an atom on the whole, compared to atomic mass unit. So this is the standard, remember. Now atomic mass unit can also be, this is the value, remember, okay, very important value. Atomic mass unit can also be expressed in terms of energy. I'm erasing these parts. atomic mass unit can also be expressed in terms of energy using energy mass equivalence. Okay, so E is mc squared, we know this. So mass, any mass is also a form of energy. Mass can be converted to energy, so to say. So this amount of mass will also amount to some amount of energy. So we want to find that value of energy. This amount of mass is equivalent to how much amount of energy, that is what we want to find. So in order to find that, what we do is 1U is, what is the value of M? It is 1.6605 into 10 to the power minus 27 kilogram into C squared. C squared is 3 into 10 to the power 8 meters per second squared. I wish I had a calculator, okay, so that I could calculate it for you. Now you do the calculations, all right, and you of course this will be meter squared, this squared, all right, meter per second whole square. This is it. So you do the calculations, like I said, you'll get the answer in joule. You have to convert that joule to electron volts, or rather mega electron volts or million electron volts, and what you will see is 1U comes out to be 931.5 million electron volts. So this is atomic mass unit in terms of energy. So either this is in terms of mass, this is in terms of energy. So this is about your atomic mass unit. Thank you.